Okay. Good morning or good afternoon, depending on where you're calling from. My name is Charla, and I want to welcome you to today's webinar, What's New in Hazelcast IMDG 4.1. Before we begin, we do have a couple of housekeeping items to go over. Everyone will be muted for the webinar, so please type any questions you may have as we go along in the Q&A panel, and we'll answer as many as we can at the end of the presentation. Also, this webinar session is being recorded and will be sent to everyone via email following the webinar. Now that we've taken care of that, I want to thank you all again for joining us. Today's webinar will be presented by Jiri Holusa. Jiri is a devoted open source software engineer that absolutely loves his work. Born in Red Hat and later Hazelcast as a quality engineer, he's now product manager of Hazelcast IMDG. Digging deep, never giving up on a problem until it's solved, and enjoying it all the way, that's Jiri. Besides that, he loves basically any sport. And of course, as a true Czech person, he never ever refuses a pleasant conversation over a pint of beer. So with that, I'm going to pass it off to you, Jiri, to get us started.
Thank you very much, Adla. So, hey everyone, just to check, can you hear me and you can see the screen? Okay, cool. So, hi everyone. Once again, my name is Jiri Holusa. Don't worry about the pronunciation of the name. I'm come from the Czech Republic, and we are probably the only ones who have that special R letter that nobody can pronounce correctly. I'm the product manager of Hazelcast IMDG, and as Charla mentioned, I was before I was a quality engineering team lead at Hazelcast as well. You can reach me out directly through any channel that you can possibly get. So through Twitter, LinkedIn, or through Slack on our Hazelcast community channel. So make sure to reach out to me if you have any questions or you're interested more. And today we're going to talk about Hazelcast IMDG 4.1. It's our newest, the best release ever, of course. And I'm going to introduce you to the main features that come in this release. This session, this whole webinar, will be basically a giant, not a giant one, but continuous live demo. So if anything goes wrong, sorry, but you know how it is. So I will try to do as much coding as possible, and we'll see how that goes. So let's get started with our journey during the 4.1. And the journey starts with actually starting the Hazelcast IMDG member. For those who don't know, the member is our terminology for, let's say, a server. Newly in Hazelcast IMDG 4.1, or basically together with IMDG 4.1, we released an initial version of a command line tool, a process manager that can get you up and running in a matter of, I would say, seconds. So it's as simple as typing HZ, which is the command line. You can the command line tool. You can see, for instance, the nice help and all of those nice things. So let's start a Hazelcast member with just HZ start. This, don't worry about the logging messages. I will explain them later because it's also part of the newest feature set, not the logging, of course, but the feature that it represents. So I have a Hazelcast member up and running. This is running in AWS on EC2 instances, just to make it a bit more real. To see what so as I mentioned, it's a command line tool, a process manager that is hidden or aliased as HZ. It can be also, as a part of that, we started to distribute Hazelcast IMDG through the package managers, and we currently support Homebrew, Debian packages, and RPM packages. So if you're on Fedora, or for instance, if you're using Yum, you don't have to do that downloading of the zip archive and unzipping it and pointing your been porting your script to that, all you do is just yum install Hazelcast, or brew install Hazelcast, or apt-get install Hazelcast, with, of course, adding additional repository. But installing Hazelcast repository is, Hazelcast IMDG software is now as simple as ever. So as I mentioned, it will install you the IMDG distribution, and it looks pretty much the same as the regular zip distribution. So you can use it just the same way that you previously did. I will keep the member running and we'll continue with our journey. The next step, obviously, is to form a cluster. After all, we're distributed storage, and what kind of demo it would be without a distributed environment? But also, it's going to demonstrate a new feature in Hazelcast IMDG 4.1, which is discovery auto-detection. When you wanted to form a cluster in a cloud, for instance, Azure, AWS, GCP, you always had to configure a discovery plugin that will actually find your other members. Now, Hazelcast has made himself, let's say, made itself even smarter, and now it can choose the discovery strategy automatically and form a cluster in major clouds with literally zero configuration. So we have that one member started from the previous step, and let's access, this is another AWS EC2 instance. So let's just run hz start. What the discovery auto detection does, that it detects that, hey, I'm running in AWS, and we can see it here in the log line, and it says, hey, I'm running in AWS, so let's take a look for other members. And as we can see in the end, the members found each other with literally zero configuration. Let's start another member on another machine, on another AWS instance, to see if it really works. Spoiler alert, yes, it does. These log lines are related to this feature. I haven't changed the logging level, but it's better. What the auto discovery does is that it searches all the instances in the region and searches it for running Hazelcast members, and also tries the ports on those instances. By default, the ports are 5701 to 5708, like the usual Hazelcast convention. So we can see that we were able to form a 3-node cluster with 3 command line, with 3 lines in the command line, which I believe can't be made any simpler. To recap, so this is this enhancement supports auto discovery in all the major clouds, which is AWS, Azure, GCP, and also in Kubernetes environment. It automatically detects the right discovery plugin, and this feature is enabled by default in 4.1, so it should work, or it will work out of the box. When we continue to our next step so basically we enhance the getting started experience now, but we also want to maybe ease up on the operational pains. So one problem that you usually have is that if you want to change something trivial in the configuration, you have to do the whole ceremony of changing the configuration file, storing somewhere on, for instance, in the cloud, in the shared storage, on somewhere else. But what if there was a better way of just changing small bits of configuration using, for instance, system properties or environment variables? And that's exactly what we provided in the 4.1 release. So let's get back to our cloud running cluster. As you can see now, right here from the logs, we have a cluster of 3 members. All of them are on different machines, and all of them have ports 5701. Let's try to change the port of one of the members, basically demonstrating the overwriting of the configuration and how it works. So let me kill the node. Obviously, we'll see that the other nodes detected that this node got killed. And let's try restarting the 3rd node. I am going to use the command line again. So I'm going to start the member again. And as I want to override the configuration using system property, I need to pass that system property to the running to the running process. So for that, as you will learn from the help of the CLI, you're doing with the minus J parameter, and let's add the parameter. So the convention right now is that all the overrides, the configuration override, starts with an HZ for members and HZ client for Hazelcast clients. And then, as you can imagine, a YAML configuration or an XML configuration, each time we go deeper in the structure of the configuration, we'll add a period or a full stop. So let's try to change the networking subsystem. So I'm going to go to the network configuration element. Then I'm going to go to the port configuration element, and there is an attribute of to change actually the port. There are other attributes like port increment, etc. And try to set it up on a different port. Let's try to run it. By the way, changing a port can be done much easier using the command line, but this is probably the easiest example that I found to demonstrate the configuration override. And let's see if we succeeded. The members are forming a cluster, and we can see right from this log line, especially here, we see that the port was changed to 5704. Basically, what we did is that we overrode the configuration, and you can do any overrides that you want in the whole configuration. So yeah, you can do pretty much anything that you want from system properties and or environment variables. So to sum up, you apply the configuration changes without the need to change the file actually that you store, which is very handy, especially in the containerized and cloud environments when you always face the problem of where do I put that configuration file. It follows, as an example, it follows this convention as for environmental variables, but in order to understand the whole convention rules, which are actually pretty simple and intuitive, but it's just hard to describe it by word, please consult our reference manual. So let's continue with our journey, and I think it's time to actually do something with the cluster, to query it, to enter data, to modify the data. Let's go to the IDE for that. So we'll see how it goes. I'm going to run just a simple script to actually fill the cluster with data, and I mistakenly chose I chose a weird region in AWS, and it's super slow today. So please trust me that this is not Hazelcast being slow. This is AWS being slow with inserting the data. What we do here is just inserting a couple of entities, couple of domain objects with different values. You can take a look in the meantime. So it's just a classic domain object with a field of a name and age. And for those who are not familiar with Hazelcast that much, we are using portable serialization format because we're going to make use of it in the end, and I will get back to that. So one of the biggest and coolest feature that we introduced in 4.1 is that we actually started to provide the SQL support for Hazelcast IMDG, and this is the initial release. It's a preview feature in 4.1, and so far it has some limited capabilities, but you should be able to taste the power when we continue with improving the features. So let's try to query the distributed cluster using SQL, the standard querying language that everybody knows for, I would say, decades. The entry point to SQL is the getSQL method in the Java client that retrieves an SQL service. So let's try to retrieve an SQL service, and now we're going to query it. The SQL service has an execute method where you put your SQL statement just like you know it from relational databases. The SQL statement, the SQL execute returns an SQL result object. So we're going to store that. And since we will need to close that in the end, we will wrap it up into try with resources clause. All right, so let's write let's write our SQL query using the standard NCSQL syntax. So let's do a select. We'll say we'll select the name of the superhero. We'll select the age of the superhero from now the name of the map that we want to query it. I put all the items into superhero map, and we can use a condition just like with regular SQL. So let's try to select superheroes that are older than a given parameter, and we can provide the parameters separately. When we have the result, we can iterate over it. So let's do the formatting. So no, I hate that. So for the result, it's SQL row. We iterate through the result because it's iterable, and now we can access it row by row, just like with relational databases. And let's print what we got. So we'll retrieve a name from the row by the name attribute. We'll retrieve age from the row by the age field. And we can print it line by line. So to take a look what kind of superheroes we have entered and with their ages. And by the way, I made up those ages. That should be about it. So we can see that executing an SQL query is simple. I can't imagine how simple it could get. So let's try running it. And again, we're going to wait for a while for the slow AWS region. But the point is that you execute the SQL query in a distributed way, in a performant way, and you don't have to take care of pretty much anything. So let's take a look at the results, and we have our superheroes that are older than 30 years old. Especially Thor is very, very old. Let me obviously you can enhance the query with some more functions. We already support quite a lot of functions. This is a link to our reference manual with the list of supported functions or expression functions as of now. So we can already do stuff with like random, stuff with strings, truncate, concatenation, and a couple of other things. So you can already do a pretty useful stuff. To recap, this is a preview feature. Implementing distributed SQL is a very big task. It will take us multiple releases in order to provide other capabilities. So as of now, we focused on having a very good basics to build upon, and we will continue in improving that. So if you have a feature that you would love to get implemented sooner rather than later, because we will get there eventually, that would be super great if you could reach out to us or me directly through any channels that I shared in the beginning. So right now in 4.1, we can't do sorting, we can't do aggregate, so we can't do order by clause, we can't do aggregations, we can't do joins, but yet we're on the way. And also the non-Java clients are already trying to implement the support as well. We are aiming for like a production feature, not quality, it's already production feature quality, but to actually recommend it for production and to add more capabilities in the next release in 4.2. So stay tuned and share the feedback with us if there is a feature that you want us to implement first. We're going to continue with the new API introduction that solves a particular problem. This GenericRecord API. So imagine you have your object, your domain objects, and in order to modify it or read it from other clients somewhere completely different, you have to have the class on your class path as well. And this is a problem that we are trying to solve with the GenericRecord API. And I think it's better to jump directly to example. So let's try to take a look at the GenericRecord basic example. I have just a skeleton here. As you can see on the left side, this is a separate project. So in the map, in the superheroes map, I was adding the domain objects of class superhero, but I don't have that superhero class now. Imagine that this is a completely separate client, somewhere completely different, on a different machine with completely different class path. So it has no idea about any superhero class. So we can directly, we just can't instantiate that object. Let's try it anyway. So I will try to get a map that is named superhero. And let's say that I want that map to be of type superhero. And yeah, even IntelliJ IDEA complains already that I just don't know what the superhero is. And up until Hazelcast IMDG 4.1, you were screwed. You didn't have any other option to actually access the attributes of the object. You can retrieve it as an object in Java, but then you can't do pretty much anything with it because you can't retrieve the name, you can't retrieve the age, you can't retrieve anything specific. And of course, you can't modify it. So let's try to use the GenericRecord, the new GenericRecord API. GenericRecord API is basically a way how to access those objects in the cluster even without having the class definition on class path. So working with unknown, pretty much unknown to Java object. So we're going to try to, now we can retrieve a key, we can a value by the key, and it will retrieve us a generic record that I will put in a variable as a value. From the value, now I can access the fields thanks to the GenericRecord API. So now I can retrieve, for instance, the name from the value, read UTF, and I will read the field name, or I will read the age of the superhero. I will read the int. And let's try that it works. So remember that on this client, I have no knowledge of any superhero object or any class, but I can still access it. I can still read from it. So let's try that I don't lie to you. So we'll print out that desired superhero together with his age. And here we go. Let's try running the example. And hopefully it will retrieve us one of the superheroes. This is a first step basically to also provide non-Java, more convenient non-Java client support. So you can also modify the Java objects out of other clients. All right, you can see that I was able to retrieve the attributes of an object, even though I don't have the definition of that object's class. So that's the whole idea of a generic record API. So far, it works with portable serializer, and in 4.2, we are planning to add a new serialization type that should be even more friendly to non-Java users and to Java users as well, to not require any interfaces to implement. Let's jump. So once, as a recap, the GenericRecord API allows you to retrieve a portable object even if the class is not on the class path, you don't know anything about it. And previously in 4.0 and 3x, you would just get a Hazelcast serialization exception because you have no idea of the what you should deserialize it like. But now you can work with the object. But that's not all. That's not all what you can do with the GenericRecord API. And it plays nicely together with other distributed computational mechanisms in Hazelcast IMDG, which are entry processors, distributed executor services. And let's try running an entry processor again, even though that I have zero knowledge about the class definitions in the map. For that particular goal, so we are going to retrieve a map that I want to operate on. So let's retrieve the superhero map again. It will be an IMAP of an integer and superhero. No, again, I misunderstood. No, I don't have a superhero here. So I have to use generic record. I don't have the class definition. And now I would like to, the goal that we'll try to do will be to change the name of the first superhero using entry processors. So entry processor is a mechanism of running code, an executable task on entries in a distributed way on the server side. Hopefully that was clear enough. So we are going to execute on a key. The key will be, let's say, the first superhero. And we are going to execute an entry processor here. But so far I don't have any here. So let's try to create an entry processor that will make me a superhero. So become superhero. As I mentioned, it's going to be an entry processor. So let's try to add entry processors. The key will be integer, as we know. The values will be generic record because I don't have the definition of the superhero class on my class path, and a return type will be something completely different. And let's implement the process class. So what we are going to do is that we can now, let's sort this up. We can now retrieve the value of an entry through the generic record. So again, I don't have any superhero class, so I will go through a generic record. I will retrieve a value from that entry. And now let's try to modify that value. Let's try to wrap it into the GenericRecord API and put it back and modify it. So here is how we can go about it. It's going to be a new record value, and value, we create a new builder, and we are going to change the internals of the value. We're going to change the attributes. So I'm going to write a new string in the field name of name. That's going to be my name. And I'll put my age in there, although it's quite confidential, but I'm 28 years old. And let's build 28. Yes, still 28. So I'm going to build that new record, and let's set the value back to the key, to the entry. So that should be about it. Let's try to go back and run that entry processor. Or actually, let's make it a bit more generic, because it would be become superhero. So let's make it a bit more generic with parameterization very quickly. So the name would be set dynamically during the execution. So does the age. And let's try to execute that entry processor. So it's become superhero. It will be my name, 28, and that should be about it. The problem here, this is not going to work. Why? Because I created the entry processor on the client, right? And the server doesn't know anything about, the server is distant. It's somewhere in Ireland, AWS region, I believe. So it doesn't know anything about the become superhero entry processor. So we have to add it to the class path of the server dynamically, for instance, using a user code deployment. But this is a standard procedure for using entry processors dynamically. So let's start user code deployment. Let's enable it on the client and add class of the become superhero class. And that should be pretty much it. So remember, in here we have on the key 0, we had an Ironman of age 40. Let's try to put me in that Avengers band. So let's try running the example. The key thing is that you can do distributed computations on any objects without having the classes or without having the right version of the classes. And this eases up a big burden of the maintenance, because you don't have to make sure that all of the clients have the same versions of that particular library. Yeah, we don't print any output. So hopefully I'm already at that band, and we are going to read the number 0 superhero using the GenericRecord API without having any definition of the superhero class. Hopefully it will work. Let's take a look. And yes, I'm humble enough to join the Avengers. So that is that is another usage of GenericRecord API. It plays again nicely with even executor services, and sooner it will play even nicer with the non-Java clients. That's a summary that I had. For more usages and use cases, feel free to consult our reference manual. And we are pretty much done with the live demo. And I'm just going to mention a couple of other features that we added in 4.1, but they are much harder to demonstrate and probably not that fun. So one of the big enhancements in terms of stability, let's say, or enhancements of fault tolerance, is that we drastically speed up migrations. So if a cluster gets in a split brain, or if the cluster gets a node disconnected and then comes back, the data needs to be rebalanced. It needs to be migrated to the other members to ensure that availability. Previously in 4.0, those migrations were done serially, and now we introduced the parallel migrations, which help to speed up the migration time drastically. I remember an experiment that we did quite recently, and that was 3 terabytes of data migrated under 4 minutes now, whereas previously it would take about 33 minutes. So that's an order of magnitude speed up. Another interesting enhancement that solids the fault tolerance mechanisms of Hazelcast IMDG is enhancements in the partial network failure detection. Terrible phrase. We added an implementation, or we implemented a Braun-Kerbusch algorithm to detect a scenario where one member doesn't see another member, but the rest of the cluster sees that member. So it's not like that one member would be kicked off by all the other members, but they actually can't agree. And there are cases where this is pretty hard to detect, and if you can't detect it, you can't really recover it. So we improved that detection algorithm, and now we can detect even those crazy scenarios where the link is only also going only one way, not the other, and corner cases that we have never thought of before. Regarding security enhancements, if you're not familiar with Kerberos, Kerberos is a quite popular authentication protocol, and we added an out-of-the-box support for it. So in the configuration, you can set the Kerberos certificates and all the ceremonies directly right there. Previously, you would have to implement your logging module yourself, which is error-prone, and obviously with security measures, usually you don't want to risk. So we are providing the Kerberos support for you out of the box. So it's just a pretty much declarative configuration. As you might know, a Hazelcast in 3.12, I believe it was, we introduced a CP subsystem, which is as opposed to AP from the CAP theorem, focusing on or provides strong consistency guarantees. And this CP subsystem is getting popular and popular. As according to the recent data, I think that it's the most popular Java implementation of the Raft protocol. And we provided new management capabilities, like having listeners on whether the CP member left the cluster, or the group majority is somehow corrupted and stuff like that. So we can actually react to the bad things happening automatically, not just looking at the logs. And last but not least is enhancements in speeding up with Intel Optane, which is a non-volatile memory provided by Intel, which introduces, let's say, it poses a cost-effective alternative to RAM storage, but also keeping the RAM light speeds. So for some enterprise use cases, this can be extremely helpful, and we were able to speed up the integration, let's say, when Optane is working as a backend storage. And there is unfortunately the white paper is not available yet, but we have written a very nice white paper on this Intel Optane improvements, all about the general architecture and also how you do what is the behavior of Intel Optane, because we invested quite a lot of research together with through our partnership with Intel. So I hope that the white paper will be available very, very soon, so you can read it. So yeah, please take a look. I'm sure you will see it through our presentation channels like Twitter. And this is pretty much about it from the major features. There are lots of things to be looking forward to in 4.2. I don't have a separate slide on that because I don't want to make any promises, but we are going to focus on SQL, on also enhancing persistence, on larger clusters, and much more. So thank you very much for listening. Hopefully it was somehow enjoyable. And now I'm happy to answer all the questions that you might possibly have, or we can chat about anything else that you want.
Thank you, Jiri, for a great presentation. Thank you, Jiri, for a great presentation. I expected nothing less from a superhero. And thank you, everyone, for taking the time out of your day to join us for today's webinar. We hope that you found it informative. We will be sending out an email with a link to the recording, and someone will be reaching out after the webinar to help answer any questions that you may come up with. So thank you again for joining us, and we hope you have a great day.